This video shall look into the production of detergent enzymes and their uses. Detergent enzymes make up 25 to 30% of all the enzymes sold. They have become common in all developed countries, with over half of all detergents containing enzymes. They can be used to remove many different forms of dirt, including proteins, starches, and lipids. The use of enzymes lowers the temperature and level of aggregation needed, saving energy and prolonging lifetimes of clothing. The two main types of enzymes are amylase and protease.
Protease is one of the most common enzymes used in detergent industry. Its function is to break down protein into smaller polypeptides or amino acids, a process known as proteolysis. This involves the hydrolysis of the peptide bond between two amino acids of adjacent polypeptide chains. For this reason, many detergents contain protease to break down and remove protein-based stains such as grass, blood, egg, sweat, etc.
Is an enzyme that catalyzes the hydrolysis of starch into sugars. It is present in saliva, where it performs the first step in the chemical process of digestion. It is used in detergents to dissolve starches from fabrics and dishes. The first enzyme ever to be produced industrially was amylase. It was sourced from fungi in 1894 and it was used to treat digestive disorders.
The storage of detergent enzyme. There are many kinds of detergent enzymes that are mentioned before. Those enzymes may require some specific conditions for their stability. However, some basic storage for both liquid and powder detergents, which are keep away from heat and keep in the closed container and low humidity, still be able to apply.
The subtopic of my part is uses and chemical therapy of detergent enzymes. I have done an experiment to compare the effects of enzymes and detergent and non-biological detergent. And also I have explained the cleaning principle of detergent enzymes and what substance can be removed by the enzymes detergents.
My part, I'm going to discuss about the differences of enzymes and non-biodetergent. Quite a few of advantages and disadvantages of both enzymes and non-biodetergent have been highlighted regarding their performances and operating conditions. Next, I'm going to talk about some of the environmental issues caused by using different types of detergents. Notice that by using non-biodetergent, it will cause several harmful effects to the environment.
Technologies for the production of protease have advanced considerably over the last 40 years. Protease is most commonly found in microorganisms, Bacillus licheniformis and Bacillus subtilis, typically from the agricultural products containing high amounts of sucrose and glucose. However, today many recombinant techniques are widely being used to increase enzyme productivity or improve the performance of the desired enzyme. These modified microorganisms are then used as the feed to the system. The selected microorganisms are seeded onto a solid nutrient agar. The medium is then fed into a small seed tank before entering the main fermentation tank. This is to increase production of enzyme in the main tank. The main tank ranges from around 40 meters cubed to several hundred meters cubed and is kept aerated. The small tank is usually 10% of the volume of the main tank. Stirred tank reactors are used to transport the air and keep the contents well mixed. The fermentation time for protease is relatively short at around 40 to 70 hours due to the tendencies of autoproteolysis. This is the self-digestion of protease. These tanks are made from stainless steel to allow easy cleaning and thorough sterilization of the substrate by direct heating using steam. Several sensors are located around the tank for extensive monitoring of pH, dissolved oxygen, temperature, pressure, airflow, off-gas analysis, and batch weight to ensure optimum conditions for enzyme growth. When protease concentration is at its maximum, the fermentation medium then proceeds into the recovery stage. Recovery is the process of separating the protease from the biomass to produce a solution of desired enzyme purity. The fermentation broth is firstly pretreated. This involves cooling, coagulation, and then flocculation. Salts such as calcium or sodium are added, followed by a flocculating agent like a polyelectrolyte. The pre-treated mixture then undergoes primary separation. Rotary vacuum drum filters are most commonly used in industry for this process. This extracts the liquid containing the enzyme, which then undergoes ultrafiltration using membranes. The liquid concentrate is then purified using methods including precipitation, adsorption, crystallization, and chromatography. The product needs to be formulated to achieve and maintain the detergent producer's specifications. Addition of polyalcohols, polyols, and preservatives help maintain the stability of the liquid protease formulations. Solid protease formulations are to be made by granulation to give specific particle sizes. The protease product is now ready to be used by detergent manufacturers.
Production and isolation of amylase. Amylase are enzymes used in the clothing and dishwasher detergents to dissolve starches from fabrics and dishes. It can be sourced from plants, animals, and microorganisms, although it's the enzymes from microorganisms that are used for industrial production. Two major classes of amylase from microorganisms are the alpha or beta amylase, or the glucoamylase. Industrial production of amylase is carried out in several steps due to the following environmental factors: nutrient supplement, pH of the medium, osmotic relationship, degree of aeration, temperature, control of the contamination of fermentation, and when aerobatic fermentation is used, purity of the medium is a very important consideration. Two main methods for fermentation remain: submerged fermentation and solid state fermentation, although it's the submerged one that is used for enzyme production. Continuous and batch fermentations are both possible for this process. In batch, production contamination is less likely because the fermenter can be cleaned between batches. However, continuous can produce more product due to not having to shut down to clean. The batch reactor can be used for different processes, whereas continuous are custom built for this one process. Batch also gives a higher concentration of amine. Submerged fermentation is often used because of the ease of sterilization between batches, and the process control is easier to engineer. The optimum temperature for the culture to grow at is between 40 and 45 degrees Celsius. The temperature is then dropped to between 27 and 30 degrees Celsius for the production of the enzyme, and the pH is slightly acidic at 6.8. The enzyme is isolated by a selective precipitation by ammonia sulfate. The sedimentation is then collected and it runs through a dialysis procedure before finally being dried out and ground up, ready for commercial use.
In this video, I would like to introduce you about how to store detergent enzyme. This video focuses on protease and amylase enzymes used in detergent. These two enzymes can keep at room temperature, but must avoid sunlight, heat, and high humidity. This experiment will investigate the effect of temperature to detergent enzyme. Firstly, pour a measured amount of starch solution into the tubes and keep it different temperature from 5, 20, and 35 degrees Celsius. Then add the same amount of amylase to the each tube. Amylase will break the starch down, and the last dish brown solution of iodine will help monitor the reaction. At 1 minute pass, drop each solution to the iodine solution. First one is 5, then 20, and finally 35 degrees Celsius. Iodine turns into the blue-black color, showing that there is still starch present. After 1 minute pass, taste again. In this time, at 35 degrees Celsius, most of starch turn into the sugar, but there's still starch present in 5 and 20 degrees Celsius. As time goes by, the starch in the warm test tubes
are gradually broken down. After 3 minutes, starch only remains in the cold solution. It may take several minutes before it changes. This is because enzymes are usually large molecules of protein, which are require energy. If the surrounding temperature is low, result in insufficient thermal energy for the activation of enzyme reaction to be achieved, which means that the reaction would be slowed down. If the surrounding temperature is too high, the molecule denatures the shape of the protein chain, which means that the enzyme lost its activity site. If the activity site changes, the substrate is no longer able to bind to it. Both temperature and pH can cause enzyme denature, so the recommended temperature for both liquid and powder detergent containing these two enzymes should be around 20 degrees Celsius to 60 degrees Celsius, and the pH is around 7 to 8 for their stability.
Enzymes such as amylase and protease can act as the active ingredients today. Now I will do an experiment to identify the uses and target of detergent enzymes. The sample is ketchup and protein is contained in ketchup. There are 2 clean plates. I smear ketchup on the plates. The cup on the left-hand side is conventional detergent and the cup on the right-hand side is enzyme detergent, which contain protease.
好到我的家人也被照料，我的朋友还为你撑腰。
Using the same flux of water to clean plates. The first one is the plate, which smeared by conventional detergent.
气得仙女都跳脚，可是人生。
And the second one is smeared by enzyme detergent.
什么都想要，你是我最重要的决定，我愿意每天在你身边苏醒，就连吵架也很过瘾，不会冷冰。
The reason is protease can break down stains otherwise hard to clean with conventional detergent. The protein can be hydrolyzed by protease, the peptide bonds that bind amino acid together to form a protein molecule are broken down to polypeptide fragments, which can easily dissolve in water. Similarly, amylase catalyzed starch-based stain to break down, releasing smaller molecules. The use of enzyme allows lower temperature to be employed and shorter time of agitation to be employed. The protease can remove blood, milk, sweat, and amylase can remove chocolate, marsh, noodle, and congee. All in all, enzyme detergents are far more effectively than non-enzyme detergents.
There are 2 main types of detergents, the biological and the non-biological detergents. Biodetergent tends to perform better as compared to non-biodetergent at optimum temperature, ideally 30 to 50 degrees centigrade. Due to its neutral pH value, when used to wash clothes containing fiber structures, they do not wear down as easily. However, the major downside of a biological detergent will be that it contains various types of enzymes. These might cause irritation to allergic skins and might cause minor respiratory failure. Besides that, with a higher operating temperature or in hot water, biological enzymes will lose their performance and is unable to remove proteins, starches and fats like they used to be efficiently. As for non-bio detergent, it can be utilized in a wide range of temperature conditions without affecting its efficiency. It functions normally in the presence of hot water. However, the high pH value of non-bio detergent might damage your clothes in long-term usage. So, have you ever thought that washing your clothes could potentially harm the environment? First of all, biodetergent is considered environmental friendly as it is decomposable naturally without much processes and does not contain phosphate or sodium components. However, biodetergent do encourage the generation of carbon dioxide, a type of greenhouse gases, during the washing process. Do you know that within a year, 300 kg of carbon dioxide can be easily generated due to the excessive usage of detergent in our daily routine? So as for non-biodetergent, it biodegrades equally well as biodetergent, just that it contains high amount of 1,4-dioxane, a type of petrochemical product. This material is carcinogenic and is main cause of tumor growth in living organisms. It does not degrade and is a persistent pollutant in underground water plants. Besides that, phosphates, sodium and other salts trace will cause non-human organic pollution. Lastly, the non-bio detergent is high in pH value and will cause seawater pollution in long term.